Hi everybody, I'm Bob, and I'm on a little adventure. If you like geology, I think you're really going to like this. We're going to go out and find some volcanic rocks that formed around the time Yellowstone is thought to be subducted up underneath the continent. I know most people believe Yellowstone was born out in eastern Oregon from a mantle plume rising up from the depths, but there's evidence showing that it was subducted up underneath the continent. But one of the problems with that evidence is there's not enough of it. For some reason, as it went up underneath the continent and the Cascades, there's very little evidence, if anything at all. But maybe we can find somewhere we're out there. What I'm really going out, though, is so I can better understand volcanic rocks myself. And so I'm doing a lot of research as I find them to see what the heck they are. Kind of relying on maybe I got some viewers who are experts and can help out and point out some of the crystals and stuff such in the rocks. So let's go out, let's collect some rocks, and then at the end of the show, I'll describe my map. Let's go. I forgot one thing. uh, if you want to read Case for the Long-Lived Yellowstone Hotspot by Victor Camp and Ray Wells, that way you know I'm not crazy. You can look into it a little bit. All right, now let's go. All right. We're going to fly into the southwest corner of Oregon, 7 miles north of the California, just above the town of Brookings. We'll be looking at some intrusive volcanic rocks. Now, bear with me. These are my first videos, are probably a little rough. First thing I noticed on this beach was this rolled up, folded shale or slate. It appears it was folded and rolled up as the intrusive was forced up out of the ground. I think there's some right lateral movement to the north, but I'm not positive about it. The rock you see above it is rhyolite. That's a volcanic rock. We're going to find some on the beach here, along with a couple other samples. Alright, our first sample I believe is syenite. It's kind of like a type of granite. I think chemically it's thought to be a remelted granitic rock. Here's the same rock with the broken face. I love that crystal up there in the top. Alright, here's some rhyolite. You can see some quartz crystal shining in there. It's definitely got the colors we're looking for. Here's the polished face of it. See some little quartz crystals trying to form as the rock cooled. This little green rock I think is chert. It's got some gray, dark colors on the inside. As soon as we get done rock cutting on this beach, we're going to go up and look at a radiolarian chert bed. So we're going to pan around here. Off in the distance you're going to see Goat Island. It's the largest sea stack on the coast of Oregon. We're going to be heading right over there. There's some more rhyolite. On the right there's some columns. Those form when the rock cools. This rock is very rough. It's not smooth at all. It feels kind of like an old sandstone. It's easy to mistake it for sandstone too until you get in there and you look closely and you find some crystals. Well, this structure, I believe, is the part of a lava dome. It's quite mesmerizing to look at. It really cools in a funny fashion. Columns going one way, dikes going the other way. If we zoom in here, this is the same rock we're looking at there. It's all boulders that are all laying around. Syenite. Alright, I'm going to walk over and we're going to take a look at this lava dome that's busted in half. Alright, I'm going to walk down that trail a little bit and then we're going to turn and take a different angle look at it. Alright, we're going to jump up a few miles to a different beach. What you're looking at there is a radiolaran chert bed. It's formed deep on the ocean floor from little seashells that were made of silica, which is the same mineral that forms quartz. It's been folded and faulted and heated up a little bit. And some of that red color is sediment from the soil coming down through the rocks. If you look closely at some chipped up sections, it'll look green. Very green. Oh yeah, that's green. Definitely mostly green, at least here. Wonder why it gets all really dark. Well, I had to do a little reading on this one when I got home. My understanding is that carbon gets in the rock, maybe hydrothermally, I'm not sure. Wow, that green is really cool right there. Wow. Wow, that's beautiful. Yeah. It's highly fractured though. Wow, I guess I'm blind. Oh, damn. All right, so I'm going to show you some chert. It's not all from this beach, from different beaches up and down the coast. Collected some through the years or whatever. Comes in many different looking little colors. Now let's throw in rock from the other beach in the mix there. Now if you look closely at the center of the one in front of it, it's got some of the same colors in there. Looks fairly familiar. I would say that we just found some more chert. You can find this chert up and down the coast from California through Oregon. Okay, now I'm going to throw that rock up against some obsidian rhyolite and take a quick look at the resemblances. Quite fascinating. It's one reason why people they hate microcrystalline rocks. It's just kind of hard to tell them apart. So the volcanic rock we collected was alkali rhyolite, about 30 million years old. And I'll tell you where we found it as soon as I explain this map. First, we're going to look at the crustal movements. Okay, here's a map of Oregon. You see the arrows are pointing in the direction that the crust is moving. These are GPS stations that they've collected data from. Now, it's not hard to see. If you take Oregon and you simply rotate it backwards, you're reversing the movement that's taken place for the last 30, 40 million years. And that puts the southern Oregon right up on top of the mantle plume as the continent migrated over it. So basically, the continent moved like this, up over Yellowstone to its present position. So you take a map of Oregon and you rotate it about 1 degree for every million years. So we put this sucker down about 30 degrees. Now what I did, I did it in sections. It went 15 degrees, cut the map, 20 degrees, cut the map, 25, cut it, and so on. So this kind of got a time lapse, as Yellowstone would have, not Yellowstone moved under. If the continent moved over Yellowstone, it'll kind of give you a little more even idea of what location it was at. So the rocks we collected were in this area, right on the coast. They're off the track a little bit, but they are sitting way up here on top of this huge fault. Bunch of heat down in here, who knows? That's why I'm checking it all out and gonna look at all the rocks that were formed in that area. So subscribe. The next episode, we're gonna go check out some hydrothermal deposits on the coast.